Okay, good day, class. Welcome back to our course on electromagnetism or electrodynamics. So, continue gihapon ta sa kaning nga chapter that this is on electric fields in matter. So, review lang sa ma-discuss last time before we'll proceed with this new topic. Okay, kani siya na-discuss na ako ni siya before. Okay. So, we discussed last time that uh, polarization can happen not only in material but also on yeah, it can happen on material and on on every object or uh, an atom maybe that comprises the electric or the electric material. For example, I have uh, atoms such as the hydrogen and carbon dioxide. Any atom, when exposed to an electric field or subjected to an electric field, it will react and it becomes polarized because the electric field will react will cause the atom to react to it. So an atom is composed of a positive and a negative charge. For the positive charge inside the atom, which is the nucleus, it is positive. It will tend to move opposite to the direction of the electric field, while the electron will move along in the direction of the electric field. So it will give you, it will make your atom stretch because of that electric field. That's why they say it's polarized. Separate siya. So, ma-display siya in a way. And not only your atom will be stretched or molecules, but because of the presence of the electric field, it can also rotate as what we've seen in our previous discussion. Here we discussed this one. So there is what we call an induced dipole. So in this case, we have the electron outside the nucleus or in the atom is attracted towards it's going opposite to the direction of the electric field while the positively charged is going along with the direction of the electric field, so must stretch in the process. Okay, and because of that the atom becomes polarized. Okay, that's the idea of polarization, and these are examples of values of the atomic polarizability of different uh, material or atoms. We have hydrogen, helium, lithium, so on. And greater the value, the greater is the atomic polarizability. And the general form of the equation of polarizability, or atomic polarizability, is in tensor form because this one is in tensor form. Okay, because the electric field can be present in all direction. It could be in the x, the y, and in the z direction. And sa lahi-lahi nga angle, kung asa nimo i-point or i-bombard ang electric field, lahi-lahi ang ihang polarizability nga component for that. Okay, we did this example. We calculated for the atomic polarizability of hydrogen atom. And we also calculated, given the polarized material, so what do you think is the potential or electric potential or the electric field of that material? Okay. And now we will going to explore on the material, specifically on capacitors and kaning dielectrics. Okay. Dielectric material are very important man siya sa application sa modern day nato nga computers, you have laptops and all. These are mainly composed of transistors, semiconductors, and more so with dielectric or capacitance. And when you have a dielectric, so it will become polarized because it will be exposed to this. So this is the capacitor. Oops. Okay, this is the capacitor. So in a capacitor, na kay duha ka plates, you have positive Q and negative Q plates. Ang purpose sa capacitor na agni siya permis sa imong any electronic circuit because this will somehow store charge or it can create a potential difference across it. So this is like a mini battery. Oops. And okay, so as I said kanina, the capacitor acts like a mini battery. Oops. So kung unsa imong gi-supply nga battery sa imong electronic circuit, that would also be the potential dinhi sa imong capacitor. Let's say uh, linear ang imong arrangement sa imong battery and the capacitor. It contains only this capacitance. So mo na ang iyang voltage. And if you have this one, so nakakaning application ang capacitor. Okay? Capacitor application niya is kanang sa ibang cellphone, the display of your screen, that's actually composed of millions of capacitance sa mga screen. And that's why gitawag po na siya og technology niya sa imong screen is uh, touch capacitive display. Something like that. Basta kay gamit niya isang capacitance. Whenever you touch your fingertip sa imong screen and your screen sa imong computer will automatically know the location of where of that point on where you touch on what area nimo gi-touch ang imong screen. So ma-locate na siya because of the change in voltage. Okay? Because of the change in voltage, your cell phone can know ni touch ka diri sa kaning portion sa imong screen. Okay? It's like this. This is your screen. So it is composed of grids. Okay? And then each anak kay has this idea or concept about capacitor. So when you touch this area, so you sa kaninga portion na i-change sa imong potential diha. Okay? So your cell phone can know or any touchscreen material will know nga na the location, the exact location of this. Okay? And in order for people to increase the value na masalay i-increase nila ang value sa capacitance, so what they have to do is to put a material in between sa imuhang capacitor to increase the value of capacitance. Okay, so they put a dielectric material. So what happens if you have a dielectric material in between? It's like a sandwich. So your dielectric material becomes polarized. Okay, polarized na siya because you have your capacitor, ang naman na siya electric field on this direction, sa electric field, and this electric field will distort or somehow distort. So ang imuhang mga atoms and molecules inside that comprises your dielectric mo react siya sa presence of the electric field. Okay? And because of the presence of this dielectric, ang imong electric field dinhi is mogamay siya, ma-change by a certain value or a certain factor because of the presence of this dielectric. Okay, so mogamay ang ihang electric field, in turn, modako ang ihang capacitance. Okay. So recall that the equation for capacitance is given by this, Q over V. So this is the capacitance without the electric. Okay. But with the presence of the electric, let's say C naught na lang na siya for original. Okay. Then we have V naught for original. So ang ma-change naman ana is yung potential, but the charge Q is the same. So with the presence of the dielectric, your new capacitance becomes this. So the same ra ang total charge, but what will change is the potential across. Okay? So mogamay man ni siya. So pag mogamay imong potential, in return imong capacitance modako siya. Okay? So charge is the same. And this one is surely greater than C naught because this is less than V naught. Okay? So tungod kay naamang kay dielectric sa imong diri, naka dielectric, it causes your electric field to be reduced by a certain factor. And with the reduction of the electric field, the value of the electric field, then you have also reduced potential. In return, your capacitance will increase. Okay? So that we can calculate for the electric constant, it's usually given by this equation, the ratio between the kanisiya with the dielectric ng capacitance and katong original. This is the dielectric constant. So C, atong i-substitute, C is Q over V, while C naught is Q over V naught. So cancel ang Q. So 1 over V over 1 over V naught, right? So, siya naman ni siya. Oops. So this is actually V naught over V. So therefore, V is equal to, this is K. V is equal to V naught over K. So we can say from this equation that the new potential is reduced by a factor of K. Okay? So ang K is it's a constant that is dependent on the type of material. Okay. Oops. So you recall also that the effect of polarization is to produce accumulation of bound charge. So you have bound charges sa imong dielectric material. So if you have your dielectric, then if it is exposed with an electric field, it produces these following bound charges. And this one is the bound charges within the dielectric. So yung volume given by this one, the gradient of P, which is polarization, and sigma B, which is on the surface. So the electric field due to polarization is due to these bound charges, right? Actually, naapay additional cost of the total electric field. So we have the polarization and also due to the bound charges, we have the total electric field is due to the bound charges and everything else. Okay? Everything else, muna to siya ang free charges that is, let's say, for this particular case, between the plates. So na diri sa plates. Okay, those free charges na not included sa bound charges. Okay, so within the dielectric, you have your total charge density, you have the bound charges, and the free charges. Okay, so we can apply the Gauss's law for this particular matter. So for Gauss' law, it reads this equation. Familiar naman ta ana, di ba? That's the differential form of Gauss's law. So Gauss's law is kana man, di ba? Right? So kana siya. Okay? So ako nang gi-cross multiply ang balid sa pikas ang epsilon naught. So we have this rho. Now this rho, the rho is the total charge density given by this. Okay. And we know from the fact that this equation is kana, this is the equation for your bound charge within the dielectric. Right? Within the dielectric. So we have that plus the free charge. And then, imuha na siyang, kaya siya ibalhin sa pikas. So that's why you have this and this, balhin sa pikas. Okay? I-transpose. Then you are left with just this, the raw F. Okay? So kaya nila mabiling. And then, i-common factor out nimo ang kani. So you can actually do that. So we have del dot epsilon E plus the polarization P is equal to the rho F. And then you have this relationship. So kani siya, it's actually this. Sorry. It's this. Okay. So this whole thing, epsilon naught E plus P equals D. Okay. Tada. It's right. It's D. So this is what we call the electric displacement. Okay. So it's like a display siya by this factor because of this polarization. Okay, bound charges. And if you have this one, this expression, so we can write we can write it simply as this form, which is very familiar nga form kay similar siya sa imuhang kani, right? Similar siya sa Gauss's law. So Gauss's law ni siya with the dielectric material. So instead of a rod, which is total charge, the electric displacement is dependent on the free charges. Okay? And you can also write it in integral form. We have this. So similar ni siya sa katong di ba? Q enclose. So kani siya is Q free charges sa enclosed niya, sa enclosed free charges. Okay, I hope that's clear. So we'll have an example. So take a look at this. So for example, you have a long straight wire carrying a uniform line charge lambda, kaning line. This one, kaning line. Line charge lambda. So na siya lambda. Lambda is charge per unit length. And it is surrounded by an insulation. Okay? Surrounded by a rubber insulation out to radius A. So find the electric displacement. So this is the insulator niya of radius A. And what I have here is if we wanted to find the electric displacement, and so since symmetric naman siya, so we can just use the Gauss's law for this type of problem. And in order for us to use the Gauss's law, we will need to set up a Gaussian surface for this. So ang Gaussian surface niya is kanilang gihapon, cylinder of radius S, like that. So we can calculate for the electric displacement inside and outside sa imuhang rubber insulation. Okay? So we can just use this one, the formula for calculating the electric displacement. We can just use the integral form of the Gauss's law with the dielectric. So we have d dot dA, which is equal to QF for the free charges enclosed. Okay. Since uniform naman siya ang iyang electric field, okay, because sa problem it carries a uniform line charge, so there's nothing to worry about. There's no there's no kanang added complexity sa kaninga problem. Okay. So we just have to take out this d, okay, sa integral, and then dA is your surface area sa imuhang Gaussian surface, which is what the area of the cylinder. Okay, the area of the cylinder is just 2 pi S L. Let's say this is L. Okay, that's L. Let's spell that out. So we have 2 pi SL, and then the Q enclosed, which is the line charge. Okay, so ang line charge is the total charge Q is given by lambda L, right? Sa Gaussian surface, within the Gaussian surface. So we can directly solve for the displacement, which is just lambda over 2 pi s. Okay, cancel ang L. And the direction is sa S. Okay, so that's for the electric displacement. You can also calculate the electric field given this given this electric displacement. Okay. So outside, by the way, this dielectric, this is true both within and outside the insulator. Okay, that's the electric displacement. For the electric field, ang formula naman sa electric field, di ba, with the dielectric is, if you can recall, we have D equals epsilon E plus P. Okay. So outside, which is S greater than A, okay, take a look at this. So this is A. So S greater than A, wala naman na kuan diha material present. So wala polarization. So that is 0. So the electric field outside is given by this D over epsilon. And so the electric field outside is just substitute mo ang D, which is lambda over 2 pi epsilon naught. So epsilon naught na siya. Epsilon naught S naught. So you also calculated for the electric field. How about the electric field inside? Can we calculate? Like inside this one, kaning the electric material, which is your rubber insulation. So in this case, it is difficult for us to calculate, or we cannot possibly calculate the electric field. We do not know. Why? Because the polarization also is, we do not know. Sa yung polarization. Okay? So later on, as we have another example, we can calculate some other material wherein polarization is known. Okay? So let's continue with this. Okay. Mabalik siya. Okay. So recall, we have this two form of Gauss's law. We have Gauss's law in differential form. This is electric displacement na siya. Right? Electric displacement. Before, the same formula itong gigamit gihapon, but electric field na siya. Okay, we did not consider man last time about polarization. So, wala yung polarization to siya. So, this time is, kingtod na to gamay, medyo realistic siya and much uncomplicated. So, we refer to it as electric displacement. So, these two versions of Gauss's law are particularly useful since they make reference of free charges, okay, for the free charges. So, free charges are the ones we are in control with. So, ang bound charges, di ta kahilabot ana, okay? So, although they are similar with the kaning as what I said kanina, na siya similarity sa electric field, ang imuhang electric displacement, there are also some very significant differences. For example, the curl of E, the electric field, is 0, but the curl of D is not. Okay, so we have the curl of D given by that, and D is given by this. Okay, so if imo siyang binagsa, so this one is definitely 0, but this one, it's not. It's not 0. Okay, so dako siya difference actually when it comes to comparing E and D. Okay, so E, the curl is 0, but for the D, the electric displacement, it's not 0 because of this non-polarization. So since this one is not 0, so there is no general potential that generates D. So wala siya general equation ba? Unlike sa electric field, D is not uniquely determined by the free charges, but it also requires additional information such as the polarization. Okay, so dili totally ma-determine ang electric displacement by just knowing the free charges, but we also have to know additional info such as the polarization. So let's take a look at another example. So take a look at this. So suppose the field inside a large piece of the electric is E naught. This one. So na ko E naught diya. So that the electric displacement is given by this. By this form. Now a small spherical cavity is hollowed out of the material. So find the field at the center of the cavity in terms of E naught and P polarization. Also find the displacement at the center of the cavity in terms of D naught and P. Letter B. So sa A is sphere na siya. So it's like if you have we don't know unsay shape sa imuhang the electric material, let's say a large piece of the electric material. So for letter A, what if hollowed out siya og sphere? So naa siya sphere diha nga hollow. Okay? So hollow siya, let's say bangag na siya or empty space. So if it is so letter A sphere, so find the field at the center of the cavity. Cavity is katong na empty space ba. So unsa ka ang iyang electric field sa center. Okay? And also unsa ka ang iyang displacement in terms of D naught and P. So you do the same also for a long needle-shaped cavity. So instead na sphere, what about if ang cavity is a needle-like? Okay? Then last one is wafer. It's like a coin, nipis siya. Okay, assume the cavities are small enough that P and E naught and D naught are essentially uniform. So mas simplify na siya because uniform ang iyahang ang values. It doesn't depend on the distance sa material. So hint, carving out a cavity is the same as superimposing an object of the same shape but opposite polarization. Oh, so if you have your material is na siya polarization na P, so tara, siya polarization na P, so ang iyahang hollow, it's actually negative P. Okay? So if this is the polarization sa material, ang polarization sa katong cavity is dira nga direction, opposite. Okay? But the same ang magnitude. So let's solve this one. So let's consider first letter A. So for letter A, we have this case. We have a large piece of the electric material, hollowed or carved out siya of a sphere ang iyang shape. So sa sulod sa sphere, you have negative P ang iyang polarization. Sa material itself is positive P. Okay? So recall nga ang electric field sa sphere, inside sa sphere, So we've actually calculated already this na sa previous na to mga videos, kindly just look it up. Okay, I think sa previous na siyang lecture, we've already calculated the electric field for a sphere, for a polarized sphere inside, and that is given by this -1/3 epsilon naught and P, which is negative P, ang iyang polarization. So that is P/3 epsilon naught. Okay? And then we can get the electric field sa center. So ang electric field sa center is superimpose na siya ang electric field sa dielectric and electric field sa katong hollow, which is given by sa sphere. Okay? So we have the electric field, which is the average, this is average macro field. Okay? Plus itong electric field sa sphere. Okay? So this is just E naught plus P/3 epsilon naught. Ba? So we can calculate then the electric displacement given this, okay, at the center of the cavity. So the electric displacement at the center of cavity is just, we have the center is equal to the E naught, right, is equal to that. Okay. So take note, ang eccentric taking care na diha ang katong polarization, etc. It's given by that. So that is E naught plus P/3 epsilon naught. O na siya epsilon naught, so this becomes na siya epsilon naught. So kani mawala na ni siyang epsilon naught sa ubos. Okay? So that's P/3. So we can manipulate this one. We have E naught na plus, pwede ko maingon nga P minus 2/3 P. It's the same thing naman na siya ani. So we have P minus 2/3 P, that's actually P/3. Okay? I didn't do anything lang nga ma-change ang equation. It's just the same. Okay? Ako nang i-change ang yung form nga may ani siya. So the reason nga akong gimunaan na, it's because I can substitute this one. Kani, familiar man na siya nga form. That is actually D naught, right? D naught man na siya. So I can actually say D naught, right? Because ang problem is, ang question is i-express man mo ang electric displacement in terms of D naught and P. So I have my D naught here, D naught minus 2/3 P. Okay, so this would be my electric displacement at the center. So this is for letter A, katong sphere. So how about for needle? So instead na sphere and cavity, sa imong, so you have your dielectric material here, na wala yung form. Could be anything ng shape. So you have a piece of dielectric material na siya polarization na padulong. Okay. Then na po siya electric field, E naught. Kasi na ako'y cavity inside, which is kana needle. Imagine nga, nipis ka na siya, it's a needle, tapos empty space sa sulod. It's cavity. So walay material diha. So you have that. So inside the cavity, if you have your polarization as P sa dielectric material, for the cavity, the polarization is opposite. You have negative P. Okay, so dira ang ihang direction. That's for the polarization. So we can consider the needle equal to a 2-point charges. So mo siya 2-point charge ang iyang uh, pagka-polarize niya. And since yung direction sa electric field, ay ang polarization I mean is in this, kay opposite man siya. So this becomes, this is like your positive Q, and this is your negative Q. It's like a dipole. Okay? Then let's say, ako center diha, and this is S. Say distance S na siya. So that's distance S. So we can calculate for the electric field sa kaninga part, sa kaninga case. So for the Q here, okay, it's given by this. The surface charge, bound charge density. Surface charge, this one. It's given by this sigma b dot dA, right? And that's equal to sigma b area. And sigma b is just your polarization, right? It's PA. So this is this is your total. It's like your total charge, right? Nasa previous to siya nga equation. Can you refer to the previous equation? And then your P dot N is actually your bound charge, sigma B. And since uniform na siya, you can just take out the sigma B outside of the integral. Then you have sigma BA. And your sigma B is just your polarization. Okay, P. And A is the surface area of the end caps of needle. Okay, so imagine gamay ka na siya. So you can calculate for the electric field at the center sa imahang needle, and it's given by this one, 1 over 4 pi epsilon naught, which is the total charge niya, which is PA, PA, over the distance, which is SO. Para ma-simplify, ano na lang. Okay, sorry about that. So this is total niya nga distance is S. So this is S over 2. So this is S over 2. Okay, so we have over R square, which is S over 2 square. So that's S squared over 4 plus, okay, minus na ni siya. Okay, this is for the bottom. Bottom is positive Q, okay, and for the top is negative Q. So you have negative 1 over 4 pi epsilon naught, and then the Q is just PA, so negative over S squared over 4. Okay. So this will just add up. So we have 2 over pi epsilon naught PA over S squared. So muna na siya ayang result. So you can, this is a top portion. So this is the electric field. So if we take the limit, meaning ang A is ang surface area approaches to 0. So the electric field sa needle, actually, ma-approach po siya of 0. And in that case, the E center, this is sa needle pa ni siya. Okay. Needle center. Okay. So sa E center, sa imahang cavity, so you have E naught plus E center as a needle. And if since we take the limit of A approaches 0, and so E needle is approaching also 0, so we have this. So we are left with just this equation. E center equals E naught. And so the electric displacement center sa needle would be E naught, E center. Okay? E naught, yeah, E center. Which is E naught which is D naught minus P, right? Jadi mana siya gikan? So the electric displacement, ano siya? Right? Ano mo na siya? D equals, right? So inuha na siyang call this, transpose. So inuha na siya E naught sa ubos. So this becomes, simplifying, we have D naught minus P. So this is your D center with needle as the hollow. Okay. Then for letter C, ano naman to siya? Letter C, the wafer. Okay, so a very thin wafer, it can be likened into a parallel plate capacitor. It's like this. Imahang nipis kay siya nga, nipis kay siya nga wafer. And on top is, you have your negative surface charge sigma and positive charge sigma. Because the polarization is in this direction, right? And it's always pointing from negative to positive. So that's the direction sa polarization. So this is just a parallel plate capacitor with uh, with an electric field in this direction, right? Dire. So we can calculate for the electric field sa wafer, which is the electric field sa imong parallel plate capacitor, which is given by this sigma over epsilon naught k hat. So kani siya na-solve na po natin siya sa previous nga video. I think kayo review na lang sa mga previous nga video. I think sa second or third video. This is for the electric field of a parallel plate. Okay, so sigma k is just P, okay? P over epsilon naught. Thus, we can calculate for the electric field sa center sa imong wafer, which is the total of the electric field sa imong electric material plus the electric field sa wafer. Okay, which is given by E naught plus P over epsilon naught. Right? So this is the electric field. So we can calculate the electric displacement at the center. So we have E naught, E center, which is given by E naught times the E center is just E naught plus P over epsilon naught. Then you have your you have epsilon naught E plus P. Okay, but this one is just D naught, right? Mawa na siya ang D naught. Tada. Uy, dapat na siya E din ha. Okay. So we have this. So your D center is just D naught. Okay. So next step would be Next topic would be on linear dielectrics. Okay, so we'll continue with our discussion uh, for the next video na lang. So stop lang sa for this topic and see you on the next video.